Welcome to this decarbonization showcase hosted by NYSERDA's Empire Building Challenge. Its purpose is to familiarize you with technologies and strategies to facilitate decarbonizing our building stock. All sessions will be recorded and posted to the EBC Showcase Series website. Each presentation will be 20 minutes, followed by 10 minutes in which the presenter will respond to your questions, which you can post in the webinar chat. And now it is my pleasure to introduce Rachel and Ralphael Kolenko of CarbonCap.
Good afternoon, everyone, and good morning to any West Coast listeners. My name is Rachel, and I'm the Business Development Manager and Analyst at CarbonCap. Thank you for joining us today. We wanted to say a quick thank you to NYSERDA for providing platforms like the Empire Building Challenge Showcase Series to feature technologies that address real-world decarbonization challenges. Today's session will highlight 3 innovative solutions from natural gas optimization to electrification, designed to support your building's carbon reduction goals. You'll hear from Ralphael, founder of CarbonCap and inventor of the FGR waste heat recovery and ExoTherm systems. The session is going to be recorded and will be available after the presentation. For any extra follow-up questions or connections, please feel free to connect us using the information provided at the end of the presentation. And I'd like to turn it over to Ralphael. Thank you.
Great. Thank you, Rachel. Again, I want to say an extra thank you to Saul for inviting us to the showcase today, and also a special shout out to Sam, Lorna, and Alex at the Heat Recovery team for endorsing us as a solution provider to New York State. We are generally excited about moving these critical conversations forward with our practical field-tested technologies and some other developments. So let's dive into it. This is one of the big problems with buildings. They lose substantial amounts of heat through their boiler stacks, stairwells, open windows, and poor HVAC controls. This results in high utility costs, uncomfortable conditions for the occupants as well. Space and domestic water heating are 2 of the largest contributors, followed by makeup air and cooling. Another issue is finding a simpler retrofit solution that actually works and provides the economic returns that building operators are looking for. So after extensive conversations with building operators, we learned there was a demand for solutions in 3 basic areas. The first area was an innovations that work with buildings still running natural gas and heating oils, perhaps that don't have the budget for any large-scale retrofits, yet still want some efficiency improvements. The second area was operators who would consider developing a larger budget, but wanted a solution that would help fix them and their current efficiency issues to be also used in the future. So when they're transitioning to electrification solutions, it would obviously make sense for them to consider a technology that is transferable. And the third area was operators willing to explore converting to a complete electrification. And that's why we came up with these 3 solutions: the FGR condensing economizer, a hybrid heat control system, and the ExoTherm network. So here's our first building issue. A large area of wasted energy in a building is right at the boiler stack. Valuable heat energy is literally blowing out the top. Most boilers run at about 83% efficiency, which means a significant portion of the energy is being lost. This isn't just wasted money, it directly drives up carbon emissions. When you walk into most boiler rooms today, you'll find that there are also few effective cost solutions in this place to recover the wasted heat. Here's a good example. This heat gun shows exactly what's coming out of the stack, and that's energy we can capture and reuse instead of losing it to the atmosphere. So our flagship system developed by CarbonCap is the FGR-10 system. The FGR maximizes the boiler's heating efficiency by fully condensing all the available thermal energy from the boiler's exhaust. This system preheats the incoming domestic water. We often see the water temperature jump from 50 degrees to 100 degrees Fahrenheit before it even hits the domestic tanks. This system also preheats the boiler's return heating loop. Its compact modular design also allows it to be easily installed with minimal building disruption. The FGR thermal efficiency is tracked by certified and calibrated energy meters that are EN 1434 compliant. And you also save in 3 ways: natural gas, electricity, and water. The live dashboards track real-time performance and reduce the boiler runtime and the carbon intensity. The first system was commissioned in February 2023 and has been running flawlessly since this time. So here is another form of wasted heat. These thermal images give us some clues where the heat loss is coming from, like poor insulation, bad seals, and open windows. But the majority of the physical heat loss is often being driven by air movement inside the buildings. That's hard to see. When the windows are open on the upper floors and the doors at the ground level open, warm air gets pulled in out of the building like a vacuum effect, creating what I like to call an invisible momentum or heat loss inertia. This uncontrolled air causes the building to fight itself. Some areas get overheated, other areas are cooler, and this imbalance consistently pulls heat to where it's escaping. If the heating system doesn't properly control for this, it leads to more wasted energy and ultimately more emissions. The heat control system fixes this by dramatically managing the heat distribution, making adjustments in real time in temperature, humidity, wind, and other building conditions. A sophisticated PLC program also smart cycles the heat load to take advantage of lower peak demand changes. The centralized heat controller is compatible with most BAS systems and offers a robust dashboard that provides useful information and log data. The heat control system has 2 options depending on the building's heating goals. Zone valves are installed on the risers in the lower floors and respond to zones set up around the building. The second option is installing thermostatic valves in each suite with thermostats that provide even greater heat control. Both configurations are done with a majority of wireless sensors that feed information to the main controller. The heat control system on average increases building efficiency by 35% or more. The system has been installed over 150 large multi-residential buildings in Canada and is endorsed by major utility companies supported by strong case studies. And this has been in reliable operation since 2009 in many building types. So one of our next problems and a major challenge is older steam heated buildings, particularly in New York City, and their piping design. Most have large riser pipes that deliver steam and a small return pipe for condensate. This limits your ability to do any upgrades. Steam heat pumps are being developed, but they're not widely proven or reliable yet for full electrification and scaling. Steam systems only provide heating. Adding centralized cooling would require a full piping overhaul. To install a heat pump system that could simultaneously heat and cool, you would require 2 channels or 4 pipes installed throughout the building. And the cost of associated doing with this in a building is quite extensive and disruptive. Even if the occupants pay for their air conditioners, PTEC units for cooling, the building's overall electrical load still contributes to the carbon penalties, so the building operator can't ignore the emissions impact. So how do we fix this? The ExoTherm network is CarbonCap's latest development that solves the challenge of converting buildings to a full electrification solution. The first thing we do is wrap the exterior of the building with a 2-channel 4-pipe network that is filled with a suitable glycol mixture. Makeup air units are also connected to the same pipe network and neatly organized in appropriate zones. Super efficient whisper quiet fan coils replace the existing rads inside each suite, and the 4 pipes are connected to each fan coil. Only 4 small holes are needed through each brick. Fan coils provided simultaneously heating and cooling all year round, and their compact low-profile design also has built-in programmable thermostats, and obviously they're easy to maintain with front panel access in each suite. Our pump supplier is trusted partner Grundfos, and they need little introduction as they have successfully supplied the retrofit global market for many years. The ExoTherm network will be utilizing a configuration called distributive pumping. This helps optimize for both flow and heating and cooling to each fan coil and ventilation unit. The Vitalis heat pump system is mounted inside a weatherproof modular container that a crane can easily drop into place beside the building rooftop. The efficiency of this air source configuration starts at about COP of 3. The Vitalis system uses natural climate-friendly CO2 R77 refrigerant. Vitalis is owned by KKVB Group, which is also part of Takeo Refrigeration, backed by 30 years of global experience and more than 8,000 installs. These modular heat pump systems can also be operated as a standalone system in many configurations and applications. We have a few exterior options to cover the pipe network, ranging from simple cosmetic covers that match the building to full insulated cladding with special covers that give access to the pipes, or a solar PV option which generates power back to the building. This slide shows the real measurable impact of our retrofit solutions. On the left, you can see the baseline building emitting about 700 tons of CO2 based on the natural gas consumption of 100,000 therms. After implementing our combined heat control system and flue gas recovery system technologies, the emissions drop by 315 tons per year. That's a reduction of over 50% in annual CO2 emissions, which is a significant step forward towards compliance and local decarbonization goals. This level of reduction not only lowers operating costs, but also building owners can avoid potential carbon fines and improve the building's sustainability profile. So why might you choose Carbon Cap? We have real hands-on experience, not just theory. We have proven technologies with successful field deployments. We specialize in dense urban complex buildings. We solve challenges in aging infrastructure in tough regulatory environments, and we deliver quick results and future-ready solutions. We're fully endorsed by New York State, and we're backed by confident local global partners. Here is a quick snapshot of some of our partnerships. Again, these partnerships help us achieve our goals and provide a real path to net zero for our clients. Every Carbon Cap solution is built to exact maximum energy conditions needed at the buildings, and we push the buildings towards their net zero goals. We're not only working on one building at a time, but our platform is scalable and can decarbonize across entire portfolios with various solutions. Our approach is fully aligned with policies like the LL97 and LL154, and we actively help clients take advantage of every available incentive to reduce both costs and carbon emissions. What makes us different is our retrofit first mindset. We're providing a real actionable path to net zero. Now, building owners don't need to wait for the next generation of infrastructure or major building overhauls to get started. This concludes our presentation today. Again, I would like to thank everyone who took the time to join live today, and to the amazing EBC team for hosting this showcase. We're excited to support everyone's decarbonization journey, keeping in mind that our solutions deliver real, measurable energy and emission savings. Also, if you don't get a question in today, please feel free to reach out to us, and don't forget to share the recording provided by the EBC Showcase website link. Thank you.
Ralphael, thank you so much, and Rachel also. If anyone from our attendees has a question, can you please post it in the chat, and I'll be glad to read it to our presenters. I'll start out with the first one. In terms of the thermal control system, you emphasized the applicability to multifamily units. I'm curious in terms of its commercial applications as well as specifically towards healthcare institutions and hospitals, which is something this current series is emphasizing.
For sure. I mean, it's quite, if you're ever walking downtown New York in the morning, as you go in between the buildings, you'll notice that all of a sudden you're warm and then all of a sudden you're cold. And the same thing's happening with the building. So when the sun is coming up on one side of the building, the heating control system is actually flowing equal amount of heat to even the warm side of the building. So what this heat control system is, it stops that from happening. It has temperature sensors inside the building, whether it's an apartment suite, whether it's a waiting room of a hospital. It'll sense where the heat is needed in the building and distribute it correctly. And it's just phenomenal, the impact of such a heat control system does on a building. And we have substantial case studies that have shown just phenomenal results in that.
Thank you. Anyone wants to pose a question, please do so in the chat. I'll ask another one regarding the ExoTherm system. It sounds like from the way you presented it, the overclad that goes with it is optional. If so, do you then have the exposed pipework, or is it integrated into the overclad panel system and it all works as one integrated unit?
So obviously the number one goal of the ExoTherm system is to get cost-effective and reliable heating and cooling into the building, which is electrified. And so that goal is accomplished by surrounding the building with our pipe network. Now you have to worry about things like the cosmetic appeal to the building. So obviously the most cost-effective solution would be covering the building pipes with a cosmetic cover. These are glycol-filled lines, so they're not affected by any temperature, but certainly affected by the looks on the outside of the building. So that's option one. The second option would be to add an overcladding and a panel, and the panel is actually proprietary. The panel will have a removable cover, so the pipes you will still have access to those pipes, but you'll still have the benefit of the cladding. And then there's two other options, and that would be just to cover the actual piping with either the cosmetic cover or with perhaps maybe even a solar panel PV cover. So your pipe networks would be around the building, but they would also be generating revenue back to the building with a panel that would cover, you wouldn't see them. It wouldn't provide the building with its thermal layer, but it wouldn't come with the price of the price point of the overcladding. Obviously, that adds a substantial cost. There's benefits to the overcladding as well. The overcladding is obviously going to provide some better R value to the building, and there'll be a reduction in the amount of overall heating and cooling power that's needed for the building in terms of the heat pump. But that involves even more engineering and costs. So I think the number one thing that we're seeing, the benefits of putting a natural refrigerant CO2 heat pump option on a building, you'd see a reduction of at least of 2/3 in its energy use. And I think maybe if you enjoyed that for a few years, you could revisit the idea of overcladding the building down the road.
Got it. And if you I'm assuming you can mix and match the BIPV vertical panels with the standard cosmetic panels if they're, particular areas that are getting sunlight, whereas not clad the whole thing in PV if you're not getting any exposure from it.
Exactly. So our exterior engineers would be able to spec that and come up with a blended solution that makes sense. Obviously, you're not seeing a lot of the PV panels on the cladding yet, but it's a growing category and certainly being exploited in various large cities globally. But we don't see any reason why the building owner can't generate revenue back to the building and provide a cosmetic cover for the ExoTherm network pipes at the same time.
Great. And just one follow-up to that, are the overclad panels, are those like a tile system, and what size do they typically come in?
They are, and it's really dependent on what's what it's being attached to in the building. So anywhere from a a 2 to a 4 foot or a 4 by 6 foot panel. It just depends on, where the windows are located, where the balconies are located. And the benefit of just having either, a cosmetic cover or a solar PV panel would be the benefits of avoiding things like the intense moisture barrier that is needed between the overcladding. That's one of the big challenges with the buildings is you can't just slap the cladding on. So in this case, it would allow the cover to breathe from behind, and it wouldn't present any other issues for the building. So there's a couple different options there depending on the goals of the building. I mean, if we put in the heat pump system and it cuts the building utility consumption by 2/3, the overcladding may be a moot point. I mean, yes, it would be fantastic to cut it by another 20 or 30%, but I mean, I think it makes sense to decarbonize the buildings rapidly, and installing the Vitalis heat pump option through our ExoTherm network would be the most cost-effective solution and the shorter pathway, in my opinion.
Got it. Well, there's a question come in related to that in terms of project economics. I understand that every project is unique, but can you give us some sense of the cost of each of these three solutions?
Sure. The FGR system for buildings that just have a gas boiler, assuming the common venting is near the rooftop, and it's fairly easy to install in terms of the pathway for the common vents. We have an average payback, and simple payback in that situation of just under 5 years, sometimes as little as 3 years. And we're talking about a total cost of a building that has maybe 4 boilers. It might be $150,000 for the FGR system. And we see an efficiency increase of about 15%. So that's a very economical. The install shouldn't take more than 2 to 3 weeks. Nobody gets disturbed in the building. There's all the activities just done in the boiler room, and the water might be off for 4 hours during the day. The second solution, the heat control system, averages about $2,000 per suite on average. So that gives you an idea of what the cost would be, and that would include zone valving at the suite levels and around the building. So that gives you a good idea at $2,000 per suite. And then the ExoTherm network, just based on the heat pump option, without the cladding, we're finding that the average price or quotation would be somewhere in the neighborhood of about $1 million a megawatt. That's probably going to do a building that has between 300 and 400 suites. And again, if you're just going with a cosmetic option, I don't see that as a phenomenal cost accompaniment to that. But the cladding option, I mean, the cladding is really where the costs get, they probably start somewhere in the neighborhood of $10 to $15 million if you're going to be cladding an entire building. Again, there's lots of companies doing cladding, lots of options, but the key to the ExoTherm network is really its piping network. Its Vitalis heat pump is the heartbeat of the system. And we're noticing an average cost of a system like that somewhere in the neighborhood of about $1 million a megawatt, depending on the heating and cooling needs of the building. But that's completely decarbonizing the building.
Thank you. Are there any other questions from the audience? If so, please post them in the chat. Regarding the overclad system, what is the projection out from the existing surface in terms of, lot line issues and things like that? And even though there are allowances for that, given current code in New York City, how far out does your panel project from the existing surface after you've applied the ExoTherm piping?
Right. Yeah, it actually doesn't add to the, thickness of it. Because there's a gully that gets carved out in each panel. It's actually sitting flush to the wall. So there's no difference in terms of any surprises in terms of the thickness of the panel. So again, we'll be working directly with the DOB on assessing each building by building location. But having said that, there is cladding that's obviously being applied to buildings. And right now, the technology does not add to the thickness of that panel. It's adapted underneath the panel and doesn't make it any thicker.
Great. Are there any other questions? All right. Well, Ralphael and Rachel, thank you so much for presenting today. Thanks everyone for attending. Oh, it looks like we have one other question come in. What is the weight of a typical overclad panel?
Sure. Well, it depends on, what the engineer has spec'd in terms of the R value and its hardware that's attaching to it. Each panel could weigh anywhere from, on the low side, probably 50 pounds up to 150, depending on, what the application is. The cosmetic covers, you're talking 10 to 20 pounds per cosmetic cover, depending on how long the section is. So there's, a cost-effective solution and then obviously a more intensive solution, and each one is associated to that weight.
Great. Last call for any questions. All right. Well, again, Ralphael, Rachel, thank you so much. Thank you for everyone attending today's presentation, and we hope you will check out our EBC Showcase website for past recordings and future ones to be posted there, and hope you can join us for our upcoming presentations in this series.
Great. Thank you.